Assalamu alaikum wa rahmatullahi wa barakatuh. I am Amr Ibrahim. In this video, I'm going to present our assignment. I will start by presenting question 1, and my friend Malik will continue presenting question 2. Here, if I open the question to understand it, this question wants us to replace this air cylinder with a suitable mechanism that will rotate this rocker throw 90 degrees from first position to the second position. Actually, this rocker is attached to the wheel link shown here, which will follow the direction of the rocker. So when the rocker rotates, the wheel link will follow it also 90 degrees from here to here. This is the second position of the wheel link, which actually attached to the rocker. In my design, I replaced this air cylinder with a crank, so it will complete a full revolution to move this rocker. So the overall mechanism will be a crank rocker mechanism. Okay, I started the design by designing the parts. This is the first part, which is the ground or frame, and here is its 2D dimension. Here is the crank and also its 2D dimension. Here is the coupler and its 2D dimension. And here is the rocker attached to the V-link and also their dimension. And here is the assembly. Originally, the assembly, the ground, the black one, was downward, but I will make it upward so I can compare relative to the question. Now, if I open the question, okay. Now, if I rotate this crank to be at the first toggle position, which is aligned to crank aligned to the ground, this is the first position of the rocker, and also the V-link which attached to the rocker, and the angle between the rocker and the coupler here will be the minimum transmission angle. If this crank continue rotating clockwise to the second toggle position here, the angle between the rocker and the coupler will be the maximum transmission angle, and this is the second position of the rocker, which rotates from here to here through 90 degrees, and also the V-link moved from being here to being here. If I want to simulate this movement, I will maybe I'll make it 5. So the movement is showing clearly here. The crank rotate 4 revolution, and the rocker move from first position to the second position through 90 degrees. That's all from me. Thank you very much.
Assalamu alaikum. My name is Malik Abu Zaid, and today I'm going to explain the mechanism of this 4-bar linkage. So this 4-bar linkage was designed to give the 3 specified positions C1, D1, C2, D2, and C3, D3 by ignoring the fixed pivots O2 and O4. So let's first have a look at the components of this linkage. The first component is the ground link, which has a length of 9.2 centimeters. Second link is 15 centimeters. And then we have the third link is 17.2 centimeters. The last one is the fourth link, it's 8.9 centimeters. We can notice that this 4-bar linkage is non-Grashof triple rocker mechanism because the sum of the shortest link, which is link 4, and the longest link, which is link 3, is bigger than the sum of the other 2 links, link 1 and link 2. So this means none of these links can make a full rotation. It can only oscillate or act like a rocker. Now let's look on the mechanism of this linkage and how it works. So if we apply motion to the input link, which is link 2, it oscillates or swings within a specific angular range. And then the motion is transferred through the coupler or the connecting rod, which is here link 3. The motion is transferred to the output link, link 4, which also acts like a rocker and oscillates with specific angle. So we can say that the coupler link 3 act like a bridge, carrying the motion between the input link, link 2, and the output link, link 4. from a technical perspective, we can analyze the toggle positions of this mechanism. So the first toggle position is at theta 3 equals 0. Theta 3 is the angle between the third link or the coupler and the x-axis. So we see that here the angle is between the angle between the link 3 and the x-axis is here 0. So here is the position, or here's the toggle positions where the mechanism change the direction of motion. The second toggle position is at theta 3 equal 90 degrees, or we can say at theta 3 or link 3 is perpendicular to the x-axis. This is the second toggle position where the mechanism change the direction of motion. So we can say that this mechanism has a range or angle range of 0 to 90 degrees of theta 3. We also can we can also define the mobility or the degree of freedom of this mechanism by looking at the number of the links. We have 4 links and 4 full pin joints and 0 half joints. This means if we apply Grubler equation, we get only 1 degree of freedom. So this mechanism have a single degree of freedom, meaning one input is required to know the locations of the other 3 links. So now finally, we can think about the potential applications of this triple rocker mechanism. The first application is the folding tools such as seats and also robotic arms where we can carry packages or boxes. So that's all for this mechanism, and thank you for your listening. I hope my explanation covered all the mechanism of this 4-bar linking. Thank you.